Welcome back. This is another exciting episode of Mr. Takeda's Teaching Math 7. This is lesson 8.4 on the areas of composite figures. A couple lessons ago we did composite figures, but we did the perimeters of composite figures, and we learned that composite figures were just figures made up of other shapes. Rectangles, triangles, what have you. They share a side, we put them together, we called it a composite figure. But now we want to find the area of a composite figure. And in some ways, I don't know if this is easier, it's kind of the same. Let's take a look here. To find the area of a composite figure, separate the figures into areas you know how to find, then find the sum of the areas of those figures. Okay. Now, it's important to know that for every little square, we're going to call this one square unit. And if we have something like that, that's half a square unit, okay? This would be half a square unit, and this would be one square unit, right? Okay, so first we need to kind of, since we're using this grid paper, we need to find all of our whole square units here. So, oops. I'm going to kind of outline it here for us. Unless I make a mistake. Let's see here. Okay, so how many square units do I have? Now I could maybe kind of go a little bit faster by looking at this. This is 4 by 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is 4 by 8. So this will be 28 here, right? 28. I'm sorry, not 4 by 8, 32. 4 by 8. This is 32 from here to here. So I have 32. I'm just kind of making a running list there. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I've got 13. And now for my little half units, I'm going to keep track of half units separately. So half units, I have 1, 2, 3, 4, 5. I've got 5 half units. So I need to multiply that by 1/2. And I get 5 halves. Since we're adding these up, I'm going to go ahead and put this into mixed number format here. 5 divided by 2 is a 2 with 1 left over. So 2.5. 1/2. 3, 4, 5, 6, 7. 3, 4. So I get 47.5 square units. All right. So I count up all the holes, all the whole units, count up all the halves. I just have to multiply the number of half units by 1/2. Right? 5 times 1/2 gets me 2.5 units. Makes sense. These two together would make 1. These two together would make 1, and I have another half left over. So 1, 2.5. All right. Try this one. Find the area of the figure. I made it real big so it's easy to count. Count up the holes, count the halves, and do your calculations. And I'll join you on the next screen. Positive. Okay, so now we need to find the area. Now we don't have the graph paper anymore, but this is very similar to what we did with perimeter, except now we just have to calculate areas and add them together. So I've got this. What do I have here? I've got this. Looks like the key from under a basketball hoop, and it's 19 by 12. The rectangular part is 19 by 12. Then I've got this semicircle here that has a diameter of 12. Okay, so let's do the rectangular part first. The rectangular part is 19 times 12. This is the rectangular. So 19 times 12 is going to equal 228. Now we'll do the semicircle. Okay, so I know the area of a circle is going to be pi. Let me just go ahead and put 3.14 here. Pi r squared. So r would be half of 12 would be 6 squared, all divided by 2, right? Because that's why this is the area of the semicircle. So this is the area of a circle. Oops. That's the area of a circle. Divided by 2 is the area of a semicircle. Okay, so this will be 3.14 times 36 divided by 2. And I can now do 36 divided by 2 is 18. So 3.14 times 18. See what I'm doing here? I'm doing the, I did the division first, so I don't have to worry about doing it on my calculator. I'm not doing the whole circle and then dividing by 2. I'm writing the formula for the semicircle, and then I did the division first. 36 divided by 2 is 18. So 3.14, oops, 3.14 times 18 equals 56.52. Okay, but now I have to put the areas of the composite figure together. So 228 plus 56.52, 14, 5, 7, 8, 284.52 square feet. All right, 284.52 square feet. The rectangular portion, the semicircular portion, and then we just add those together. Okay, we're going to do this example in class, and we're going to have, so we'll do this example here right now with you on the video, finding the area. So there's no circles here, but there are triangles. Now, important thing remember about triangles is that they're half of a rectangle. One thing you can do to help organize this for yourself is kind of, you might want to, as you draw this out, and then label the regions, because I actually have 4 different regions here, so this is going to take a little bit of time. So for region 1, it's a triangle, and the triangle is based on this rectangle, 11.2 times 4.5, right? It's this and this, but it's half of this rectangle. So I'm going to take this rectangle and divide it by 2 and come up with this area for area 1. So this will be 4.5 times 11.2 and divided by 2. Okay. So 4.5 times 11.2 is 50.4 divided by 2 equals straight down. So this would be 25, 25.2. That's region 1. All right, it's region 1. Region 2, I'm using, this is a rectangle, and this is just straight 8 times 4.5. So rectangles are easier. 8 times 4.5. 36. Now I might have made a mistake when I said this is going to be 3 and 4, because this isn't a regular thing. So what I'm going to do, I'm going to get rid of area 4, and I'm going to treat this whole thing as a trapezoid. So the whole thing about this trapezoid is I can just take this base times this. We call this a height in this case. We don't call it we call this a height. So these are bases and these are we call height. But what we call them doesn't matter. Maybe you can kind of imagine that if I cut this rectangle out and I stuck it over here, I'd have a rectangle, right? So I can just treat this as a rectangle. I can just treat this as a rectangle. That is area 3 is going to be 8. This is 8, and this is 8. And this height is 6.7. So this got easier. I thought I was going to do more rectangles, more triangles. 8 times 6.7, because that's our trapezoid, 53.6. Okay, now I need to add all these together. So total 25.2, 36.0, and 53.6. And I'm going to have, let's see, 8.8. I have 9 and 5 is 14, so 4 carry the 1. 1, 2, and 3 is 6. 6 and 5 is 11. So it looks like it's going to be 114.8 square centimeters. Okay, so there's a lot. This is why I didn't do any other problems for you guys to do on your own, because there's a lot of steps here. But we'll do a lot of these in class. All right. I think that's it. That's for in class. All right, so that's it for this video. Lots to take in here, but we'll practice this in class when I see it. All right, guys, I'll see you then. Bye-bye.